Okay, today we're talking about heat pumps. So in order to understand a heat pump, we need to first understand how the refrigeration cycle works and what are the main components in an HVAC system. Whether you're talking about in your home, AC system, your car, or your refrigerator. So how a refrigeration system works is you have a condensing coil on your house that would sit outside. The condensing coil is the heat rejector. And you have a condenser cooling fan that is responsible for pulling ambient outdoor air through the condenser coil, absorb the heat energy from the refrigerant flowing through the coil, and discharge it up and out away from the building via the fan. And the compressor is the pump. The compressor increases the pressure and the temperature of the refrigerant as it flows through the condenser coil. Once it leaves the condenser coil on the liquid line, it goes to a metering device or expansion valve, where the refrigerant then immediately reduces in pressure and temperature, goes through the expansion line into the evaporator coil inside your furnace or air handler in your house. Inside that furnace or air handler, you have a blower. When the blower is on, it sucks return air through the return filter, through the blower, up through the evaporator coil, where that warm ambient air inside your house, that heat energy in that air is given off to the cooler refrigerant that's flowing through the evaporator coil. Thus, the air coming out the other side of the evaporator coil feels cooler and goes out your supply registers as cool air. So an air conditioning system does not make cold air. Even in your refrigerator, you're not making cold air. You're simply removing heat from one place and rejecting it somewhere else. So on your refrigerator, when it's running, you'll notice the inside will be getting colder, but you'll feel warm air coming out the back or underside of your refrigerator. That's because the condenser coil and condenser cooling fan is rejecting that heat energy out into the kitchen. Same thing with your air conditioning system. If you have a split system like this, and you notice on a hot summer day that condensing unit that is running outside has warm, hot air blowing out the top of it. That's normal. It's rejecting that heat energy. So we're removing the heat energy from the air inside your house via the refrigerant and transferring that heat energy to the outside of your house to be rejected. And the cycle repeats itself over and over and over again.
Wow.
Now, if you have a mini-split ductless system, they have the same basic components, they work the same basic way, only as the name implies, a ductless system does not have ducts throughout your house. You just have the head unit that is attached to the wall inside your house and blows cool air into your house. You may have multiple head units throughout your house or facility. Now, there are some mini-split ductless systems that are heat pumps. So some mini-splits are just air conditioning only. Some will do air conditioning and heating. So keep that in mind if you're going to purchase a mini-split system. Same thing with a standard split system like you see here in this picture. Some just do air conditioning. But if you specifically buy a heat pump, the key difference between a standard split system and a split system that is a heat pump, the heat pump system, yes, will provide cooling in the summertime, but it will also provide heating in the wintertime. The key component in a heat pump system that accomplishes this task is a four-way reversing valve. And basically the way this four-way reversing valve works is this line here is attached to the discharge line of the compressor. As refrigerant flows into this four-way reversing valve, depending on what position the valve is in, the refrigerant will flow to the condenser coil, as in cooling mode in the summertime. Or conversely, if you reverse the position of that valve in the wintertime, that refrigerant will flow out of the reversing valve to the evaporator coil or your indoor coil. So how does that work? Well, as a refrigerant flows into the indoor coil through that reversing valve, it's going to give off the heat energy that it collected outside. So even on a cold winter day, there is still heat energy in the ambient air. And the refrigerant can absorb that heat energy. And then that heat energy is then transferred again via the refrigerant inside your house to the indoor coil. The blower fan blows over that warm indoor coil, and you get warm air coming out of your supply registers. And then the refrigerant flows back outside, picks up more heat energy, brings that heat energy back inside, and the process repeats itself. So essentially, a heat pump reverses the direction of flow of the refrigerant, and instead of rejecting heat outside and absorbing heat inside to cool your house, you're absorbing the heat energy outside and bringing it inside to warm your house. Whereas a standard furnace that is gas-fired, or if you have electric heat strips, you're burning fuel or using electricity to generate heat to heat your house. Heat pump systems will usually have 2 metering devices and 2 check valves. So there'll be 1 metering device and 1 check valve on the indoor air handling unit, and 1 metering device and check valve on the outdoor unit. Usually, heat pump systems will be a little bit more expensive up front to purchase. They're a little bit more complicated. They have a little bit more components. And if you live in a really cold climate, you may find a heat pump doesn't quite warm the air in your house as well. It may feel a little bit cooler. In those cases, if you live in a really cold climate and you want to use a heat pump, you also may need to have auxiliary heat strips or a second stage heating, where if the heat pump can't satisfy the thermostat setting for heating, then those heat strips will kick on to help satisfy the thermostat. So I hope this short video helps clarify what a heat pump is and how it works. Please like, share, subscribe, leave me a comment, and thanks for watching.